welcome you again. So in this lecture we will discuss about some questions from the exercise 8.1. Okay, we have completed every examples from that exercise. Okay, so let's start with the first question from exercise 8.1. Okay, so the question is the angles of a quadrilateral, okay, are in the ratio 3:5:9:13. Okay, so it is given if there is a quadrilateral. It is not given which type of quadrilateral it is. Simply it is a quadrilateral. And in this quadrilateral ABCD, four angles are given. Okay, and they are in the ratio 3:5:9:13. Okay, so we can take let ABCD is a quadrilateral. Okay, since each angle's ratio is given, so we can take, let out of the four angle A is how much? 3x, angle B is 5x, angle C is 9x, and angle D is 13x. Okay, so 3x, this is 5x, 9x, 13x. So all the four angles are being given. Now we have to find all the angles of this quadrilateral. Okay, we have to find the value of angle A, angle B, angle C, and angle D. How? See, since it is a quadrilateral, then we know the sum of all the interior angle of a quadrilateral is how much? It is 360 degree. So we can write sum of interior angles of a quadrilateral. I can write sum of interior angle of ABCD is how much? Is 360 degree. We know it by the formula n minus 2 into 180 degree. We know it. Okay, here n is how much? N is 4. If you substitute the value of n, we will get 360 degree. Now sum of interior angles means all the sum of four angles, angle A plus angle B plus angle C plus angle D. It is 360 degree. Angle A is 3x, angle B is 5x, angle C is 9x, angle D is 13x is equal to 360 degree. Add all the four angles, 13 is 22, 24, 2, 5 is 27, 30. So 30x is equal to 360 degree. So the value of x is 360 degree divided by 30. 0, 0 cancelled out. 3, this is 12. Okay, so we get finally that the value of x is equal to 12 degree. Now we find the value of x. Now this value is substituted in each of the angle to find their original value, right? Since we know angle A is how much? 3x, 3 into x, it means 3 into x is 12, 36 degree. Angle B is 5x, means 5 into x, 5 into 12, that is 60 degree. Angle C is 9x, so 9 into x, that is 9 into 12, that is 108 degree. And angle D is 13x, that is 13 into 12, that is how much? It is probably 156 degree. So in this way, by the sum of interior angles of the quadrilateral is equal to 360 degree, we can find the value of x, then substitute it in each of the individual angles, and we will get individual angles value of this quadrilateral. Okay, so now let us understand the question number 2. In question number 2 it is given, if the diagonals of a parallelogram are equal, okay, then so that it is a rectangle. Okay, so it is given the diagonals of a parallelogram are equal. Already we know in case of a parallelogram, the two diagonals are of different length. We know it. Let's say ABCD is a parallelogram. Okay, so in this parallelogram there are two diagonals AC and BD. According to the property of parallelogram, we know in case of a parallelogram the two diagonals may be equal or may not be equal, but definitely we take it as unequal, as we have discussed in the properties of parallelogram, that AC and BD are of unequal length. Okay, but according to the question is the diagonals of parallelogram are equal, but for this question we have to take that AC is equal to BD. Then if it happens, if the two diagonals are equal, then this parallelogram is known as a rectangle. It is known as a rectangle. Okay. So the condition is we have to take that these two diagonals are of equal length, and we have to prove that this ABCD is a rectangle. Okay, rectangle is also a type of parallelogram. So we have to prove that ABCD is a rectangle if AC is equal to BD. Okay, so let us first write the given statement. So it is given ABCD is a parallelogram. ABCD is a parallelogram. Okay, since it is a parallelogram, then we know the pair of opposite sides are equal and parallel. Okay, so we can write that AB is equal to DC, AB is equal to DC, and AD is equal to BC. As well as they are also parallel. As well as AB parallel to DC and AD parallel to BC. Is it clear? Also it is given that their diagonals are also equal. Their diagonals are also equal. So it is given SC is equal to BD and SC is equal to BD. Okay, so these are diagonals. Understood? So what we have to prove? We have to prove ABCD is a rectangle. ABCD is a rectangle. So let us prove. In order to prove any quadrilateral, to be a rectangle, which property should be satisfied? Tell me. In order to prove any quadrilateral to be rectangle, we have to prove that their opposite pair of sides are equal and parallel. Yes or no? Yes. And second thing is each angle must be 90 degree. If we can prove these two properties, then we can say yes, a quadrilateral can be a rectangle. Okay. If we consider this case, it is a parallelogram. So already it is given that the pair of opposite sides are equal and parallel. It is already given. So the next property is, if we can show each angle is 90 degree, then definitely it will be a rectangle. So our intention is to prove or is to find the value of each angle. If it is 90, then it is a rectangle. So let's move ahead. So for this we have to consider two triangles. Triangle ABC. Which triangle? Triangle ABC. And triangle BCD. These two triangles. We have to consider these two triangles. So I can write between triangle ABC and triangle BCD. We will compare these two triangles. First case, in the triangle ABC, AB, and in the triangle BCD, DC are equal. Why? Because it is a parallelogram, so this side is equal to this side. So I can write AB is equal to DC. Clear? Second condition. For the triangle ABC, okay, BC is a side. And for the triangle BCD, BC is also a side. So BC is the common side. Clear? The first statement is given already. Third statement. Okay. Now for the triangle ABC, okay, this triangle, SC is a side. Yes. For the triangle BCD, right, BD is a side. Yes. So SC is a side and BD is a side. But already it is given that SC is equal to BD. The two diagonals are equal. Already it is given in this question. SC is equal to BD. So we can write SC is equal to BD because it is given. The diagonals are equal. It is given. Okay. So this is side, this is side, this is side, this is side, this is also side. So by SSS congruency, we can write that these two triangles are congruent. So hence, by SSS congruency, triangle ABC is what? Is congruent to the triangle BCD. Is it clear? So we have proved that these two small triangles are now being congruent. This triangle and this triangle. Okay. Now, next step. As you can see, if we consider ABC as a triangle, right? Then this angle B is an angle for the triangle ABC. Yes or no? Yes. True. Similarly, if we consider the triangle BCD, right? C is also an angle. So C is an angle for the triangle BCD. But recently we have proved the triangle ABC is congruent to the triangle BCD. If any two triangles are congruent, then their corresponding parts must be equal. So you can write implies angle B is equal to angle C. Yes or no? Yes. Why? It is due to exam 7.2. Yeah, CP. So what do we have proved? We have proved the value of this angle B is equal to this angle C. Okay, it is done now. We can make a box of it. It is clear? Okay. Next. So next what we will do? Since ABCD is a what? ABCD is a parallelogram. Since it is a parallelogram, we know the sum of any two consecutive angle is how much? Is supplementary. That means is 180 degree. Okay. A and B are supplementary. BC are supplementary. CB are supplementary. Or AD are supplementary. So the sum of their consecutive angles are 180 degree. So you can write B plus C. As we know what? B plus C is 180 degree. Why? Because they are consecutive. Understood? They are consecutive angles and it is a parallelogram. Now I can write here since there is no space. Okay. Now B plus C is 180 degree. Already we know that angle B is equal to angle C. Okay. So in the place of B, can we substitute C? Because B is equal to C. Okay. And plus C is 180 degree. So C plus C is 2C is 180 degree. Now C is 180 degree by 2 is equal to how much? Is equal to 90 degree. Okay. So finally we found the value of C angle is how much? It is 90 degree. We have proved it. Okay. So angle C is 90 degree. Already we know angle C is equal to angle B. Then what will be the value of angle B? It must be 90 degree. It must be 90 degree. Okay. So we can write is equal to angle B. Clear? Again, for a parallelogram, the opposite sides are equal. If it is 90, then D angle is definitely 90. So you can write D is also 90. And if C 90, then this A must be 90 because they are also the opposite angles. It must be 90. So angle A is equal to 90. Okay, now we have done. Okay, so what we have found? We have found that though it is a parallelogram, and in this parallelogram, each angle A, angle B, angle C, angle D, each angle is 90 degree. And I have told you, in order to be a rectangle, two property must be followed. First thing, the pair of opposite side must be equal and parallel. It is also equal and parallel. Why? Already it is given it is a parallelogram. So that the pair of opposite sides are equal and parallel. And the second property, each angle must be 90 degree. And here we have proved that each angle is 90 degree. Clear? So finally we can write, yes, now we have proved. Hence, ABCD is a what? ABCD is a rectangle. It is a rectangle and it is proved. Okay? You understand this? So let's move to the question number 3. According to the question number 3, it is given if the diagonals of a quadrilateral bisect each other. Okay, simply it is given if the diagonal of a quadrilateral, if in a quadrilateral it has two diagonals, if the two diagonals bisect each other, okay, then at right angle, both the diagonals bisect each other at right angle, then that quadrilateral is a rhombus. Okay, so what is given in the question is given, suppose this is a quadrilateral. Okay, it is not given which type of quadrilateral it is. No, it is not given. It is only given that if it has two diagonal AC and BD, then these two diagonal bisect each other. Okay, that means if this is the point of intersection of the two diagonal, then this is equal to this, means AO is equal to CO. It means AC is bisected. Similarly, BO is equal to DO. So the two diagonals bisect each other at right angle. At right angle means the angle between them is 90 degree. Here it is 90 degree, right? It is also 90 degree and it is also 90 degree. Understood? So in a quadrilateral, if any two diagonal bisect each other at right angle, then we have to prove then this quadrilateral is a rhombus. Okay. So let us first write the statement that are given here. So ABCD is a simple quadrilateral. Okay, in which it has two diagonal AC and BD and both are bisect each other. So you can write AO is equal to CO, and BO is equal to DO, and angle between them is 90 degree. So AOB, BOC, COD, DOA is equal to 90 degree. We can write and AOB is equal to BOC is equal to COD is equal to DOA is equal to 90 degree. It is given, and we have to prove that ABCD is a rhombus. So how can we prove it? In order to prove it, we have to remind the properties of rhombus. So what are the properties of rhombus? According to a property of rhombus, we know if in a quadrilateral all the four sides are equal and the two diagonals bisect each other at right angle, then it will be a rhombus. Okay, so in order to be a rhombus, first of all we have to prove that each side are of equal length. This is the first property. Second property is the two diagonals bisect each other at 90 degree. Already the second property is given here, that the two diagonals bisect each other at right angle. So we have to prove the first property, that each side of this quadrilateral are equal length. Okay, so let us prove it. In order to prove it, we have to consider each triangle that are formed here. How many triangles formed here? Here 4 triangles are formed. We have to compare all those 4 triangles. Okay, so let us first compare these 2 triangles. So first triangle, then we will compare these 2 triangles. Okay, then we will compare these 2 triangles, right? Understood? Then we will compare these 2 triangles. So we have to compare 4 triangles. Let us first compare AOB triangle with BOC triangle. Okay, so between triangle AOB and triangle BOC, right? See, in this triangle, this side AO is equal to, in this triangle, this side CO, because it is already given AO is equal to CO. So we can write AO is equal to CO. Done. Second, for this triangle AOB, OB is a side, and for the triangle BOC, OB is also a side. So OB is the common side. OB is the common side to both the triangle. You can write common side. Okay. Third condition, for the triangle AOB, this is 90 degree, right? Which angle? AOB angle. AOB angle. And also for the triangle BOC, this is also 90 degree. BOC angle is also 90 degree. Understood? So we have found 3 conditions here. Which 3 conditions? Side, this is another side, and this is angle. So this angle is the included angle. So side, angle, side. Side, angle, side. So by side angle side congruency, we can prove that these two triangle AOB and BOC are congruent. So triangle AOB is congruent to the triangle BOC. Do you understand this? So we have proved these two triangles are congruent, and as you can see, AB, if we consider AOB as a triangle, then AB is a side of the triangle AOB. Okay. Similarly, BC is a side of the triangle BOC. And recently we have proved that these two triangle AOB and triangle BOC are congruent. That means if any two triangles are congruent, then their corresponding parts must be equal. So you can write AB is equal to BC. What you can write? You can write AB is equal to BC. Understood? So we have proved this two triangles are being congruent now, so that we will prove AB is equal to BC. Okay. Next we will consider these two triangles BOC and COD. Okay. So between triangle BOC and triangle COD, first condition. For the triangle BOC, this side is equal to, for the triangle COD, this side, because BO is equal to DO. Simply you can write BO is equal to DO. Second condition, this angle is 90 degree, here this angle is 90 degree, so they are also equal. So BOC angle is equal to COD angle. So BOC is equal to COD is equal to 90 degree. Okay, since there is no space, it is very congested to write. Next is, for the triangle BOC, this side, CO is a side, and for the triangle COD, CO also another side. So CO is the common side. So CO is equal to CO. Why? Because you can write common side. Okay. So again by side, angle, side, these two triangle can be congruent. So you can write triangle BOC is congruent to which triangle? To the triangle COD. So we have proved these two triangles are now congruent. Understood? Next, we know BC is a side for the triangle BOC and CD is a side for the triangle COD, and we have proved that these two triangles are now become congruent. So we can write their corresponding sides must be equal. So BC is equal to CD. We can write BC is equal to CD. Let's say this is our equation number 1. This is equation number 2. Okay, equation 2. Next we'll consider another two triangle. Which two triangle? This triangle and this triangle. Triangle COD and triangle DOA. So between triangle COD and triangle DOA. Okay. Here also same things will happen. For the triangle COD, this side is equal to this side because it is given. AO is equal to CO. It is given. So you can write AO is equal to CO. Second condition, for this triangle, this angle is 90 degree. For this triangle, this angle is 90 degree. So COD is equal to DOA. So COD angle is equal to DOA angle is equal to 90 degree. Third condition, COD triangle, so DO is a side, and for triangle DOA, DO also side. So DO is common side. So DO is common side to both the triangle, common side. Okay. So now by SAS congruency, we can prove the triangle COD is congruent to the triangle DOA. Okay. So we have proved that these two triangles are now become congruent. So for the triangle COD, CD is a side for the triangle COD, and for the triangle DOA. Okay, for the triangle DOA, what we have proved, or DA or AD is a side. Since we have proved that triangle COD is congruent to the triangle DOA, that means their corresponding parts must be equal. So we can write CD is equal to AD by CPCD. Let's say this is our equation number. Okay. So we have proved that these two triangles are congruent. So this side is equal to this. Okay. Now we do not need to again consider these two triangles. No, we do not need. Only these three conditions or three cases we have to take in. Now from the first case we have found. So from equation 1, equation 2 and equation 3, what we have found? Let's understand. Let's analyze. For the first equation we have found AB is equal to BC. That means this side is equal to this side. For the second equation we have found BC is equal to CD. This BC is equal to CD. And for the third cases, from the third equation we have found CD. This CD is equal to AD. So we can write CD is equal to AD. Okay, this is the final conclusion that we have found. So what we have found? We have found for this quadrilateral AB is equal to BC is equal to CD is equal to AD. It means in this quadrilateral all the four sides are of equal length. Okay. So we can write, since in ABCD quadrilateral all the four sides are equal, hence it satisfies all the conditions of a rhombus. Hence we can say this quadrilateral is nothing but a rhombus. Okay, so finally you can write, hence ABCD is a rhombus. Understood? So according to this question, if in a quadrilateral the two diagonals are bisecting each other at right angle, then this quadrilateral is a rhombus. Okay.